Hi, this video is going to go through question 2 from the A2 November test, and we're going to look at a Boltzmann distribution in this question. So it was a 6-mark question, and there were various ways to kind of get different marks. It wasn't just 6 set marks that you could achieve. What you needed to cover were the 3 scientific points and cover them in detail. So they were looking to get high grades. You needed to have a well-developed explanation, which was clear and logically structured. So I'll go through the different ways you can kind of get marks and how it can get put together. So the first thing is the Boltzmann distribution itself, and you needed a curve that started at the origin, and the curve then doesn't touch the x-axis again at high energy. You needed the axis labels. So the y-axis was number of molecules, or you could have had number of particles there, and the x-axis is the energy. So that was kind of one of the scientific points that you needed. You then needed 2 activation energies labelled. The initial activation energy, which I'm going to label EA, and then a lower down one I'm going to label EC. So the activation energy with the catalyst, or EC, had to be at lower energy than the activation energy here. And that was kind of the diagram. For your explanations then, I had to say that with EC, or with the catalyst activation energy, we've got more molecules with more energy. Or EC, there is a greater area under the curve past EC. So EC, as we go past, we've got a greater area there. The next thing you got marks for in this was to say that with a catalyst, or the advantages of a catalyst, we've got reactions taking place at lower temperatures, or the reaction can take place at lower temperature. And for the environment to impact on this, so environment, make sure I spell that right, and we can say that there's reduced CO2 emissions, or we burn less fossil fuels, so we could say there, or potentially there'll be less waste. It wouldn't allow less global warming. You needed to be specific with either less CO2 emissions, or less burning of fossil fuels. You said different reactions possible with better atom economy, or less waste from using a catalyst, or less hazardous chemicals. That can also go in there. So you kind of 3 scientific points with a graph, the explanation of the graph, that now you've got a greater area under the curve past EC, so you'll have more successful collisions. And then the final scientific principle was use of the catalyst, that it can take place at lower temperatures, got reduced CO2 emissions or less waste. And that's question 2.